Hey folks, this is section 7.1 talking about parabolas. The first thing that I'd like to walk you through is all of the different parts of a parabola. You'll notice that we have parabolas that are concave up and concave down. These are much like what we had back in college algebra. But what's different is that I'm also going to have parabolas that are concave right and concave left. Remember that concave is how they open up. So I can open up on my parabola, I can open up, down, right, or left. Now, looking at the pieces of my parabola, let's take a look first of all at the very most important point of the parabola, and that's going to be my vertex. This is the turning point of my parabola. My parabola's vertex is always going to be called HK, and it doesn't matter if it's an up, a down, a right, or a left. You'll notice over here on the concave right parabola that my vertex is still named HK. Secondly, there is a point on the inside. This guy is called the focus. The focus. This is a lot like the receiver inside of a satellite dish or a light bulb inside of an old flashlight. And so this is the focus. The third thing I'd like to point out to you on this picture is going to be the axis of symmetry. The axis of symmetry. You remember from Math 110 that symmetry is something that cuts a graph in half. And so this is my axis of symmetry. It's a line, so when I name the axis of symmetry, I'm always going to use the equation of a line. In this case, it's a vertical line, so it'll be x equals h because it's going right through the vertex at h. However, over on my concave right parabola, my axis of symmetry is horizontal, so that axis of symmetry will be y equals, because horizontal lines are y equals a number, y equals my k value. So that's the axis of symmetry. It cuts the parabola exactly in half. And then the last thing I want to point out to you is the directrix. And you'll notice in the next picture, the picture to the right of that, the focus and the directrix are both a distance of c away from the vertex. They're the same distance away from the vertex. Now, I've given you two different equations, so let's notice the difference on these. This is my first equation where it's my x pieces that are squared, and this is my second equation where it's my y pieces that are squared. When my x's are squared, I have my normal parabolas that I had back in college algebra, the concave up and the concave down parabolas. When my y's are squared, these are the new parabolas, and this is where I have a concave right and a concave left. So the way that you know which equation to use is to determine first, is it concave up or down? Then that's going to be x squareds. If it's concave right or left, it's going to be y squareds. Now, how do I know if it's going to be up versus down or right versus left? You remember from college algebra that the up and the down was all determined on that a value that was out in front in the ax squared plus bx plus c. In this case, the way that you determine whether or not it's up versus down is going to be based on this c value. If my c value is positive, it's going to be concave up. If my c value is negative, it's going to be concave down. Same thing over on the concave right and left. If my c value is positive, then it's going to be concave right. If my c value is negative, it's going to be concave left. I've also made this statement here that the focus and the directrix are c away from the vertex. I've already said that and showed it in that second picture, but that's just to restate it.